Welcome back. Let's look at some more compound interest now. We're going to keep working with the formulas we've learned previously, but to do more things now and be able to answer more questions. The first one of those is being able to calculate or work out the term of an investment. So how long will things take? That's a pretty common finance question. How long will it take for my investment to grow to become a certain amount? Or how long will it take to earn a certain amount of interest? That sort of thing. We know the rate, we know the amount that we're starting with, we know how much we want to end up with. How long will that take? All right, so like I said, it's a pretty typical problem. What we're going to do is rework our future value formula to solve for n. And so let's have a look at that. The basic future value formula was present value times 1 plus I to the power of n. So n is up in the exponent there. How do I get that all by itself? Well, let's start just working our way through. So I'm going to first divide both sides by PV. That's going to get rid of it from the right-hand side. And I'll end up with something like that. Now to get an exponent down to the main line again, we can use logarithms. You might not remember much about logarithms, but that's okay. All we really need to know is that they kind of help us calculate an unknown exponent. They're almost like a reverse exponent. So if I were to take the log of both sides, and that's the symbol for log is ln, you'll find that button on the left-hand side of your calculator. So I'll take the log of everything over here on the left, and I'll take the log of everything on the right. Well, if I do that, the n leaves the exponent area and drops actually out front down here to the main line. That's great. That's exactly what we want, because now we can just go ahead and divide both sides by the log of 1 plus I. And that leaves n all by itself. And then we'll flip it left to right, and then we'll have our formula that we want to write down and remember. So n is a log of future value over present value divided by the log of 1 plus I. All right. So once we got that, we're good to go, right? So that's what we want. Let's have a look at it. How many years will it take to earn $1,000 interest on an investment of $8,000, earning 6% compounded monthly? All right, so let's write down all the basics here. We have an investment of $8,000. We want to earn $1,000, so that means we're going to have to get to a grand total or a maturity of $9,000. The 8,000 plus 1. And we have a rate here of 6% compounded monthly. So I'm working in months in this question. That gives me a little I of 0.005. It's a how long question. I'll put a question mark there. Notice it says, by the way, how many years. So whatever I get, I'm going to have to convert back to years. In this case, the rate is compounded monthly. So my answer will be months. So I'll have to keep that in mind at the very end. You'll see. So let's go ahead and work our way through this one. Let's start with the formula. The log of future value over present value divided by the log of 1 plus I. We'll go ahead and put some numbers in there. That's the log of 9,000 over 8,000 divided by the log of 1.005. You type that in your calculator. We get 23.6154497. And then we have to stop, and this is worth kind of being deliberate or slow about. What units is this? Well, this is going to be in the same units that we were compounding the rate in up top. So this is going to be months. So about 23 months, 23, 24 months. How do I convert that to years? Because that's what the question asked. Remember up at the very top here, how many years? Well, to convert from months to years, you just divide by 12. And if we do that, we're going to get 1.97 years. And like usual, I'll go to 2 decimal places. So just under 2 years, you'll have your $1,000 interest on your investment of $8,000. That's all we have to do. By the way, a little tip for you when you're working with your calculator. When you press the log button, you want to press it after you type in the number. So for example, if we're doing the log of 1.005 there, you type in 1.005 and then you press LN. That'll give you the log. Okay, so it works sort of in reverse on our calculator, but it does make entering things a lot easier. All right, let's give you a chance to try one out. I want to look at how many years it'll take to double your investment if you can earn an interest rate of 15%, so that's a pretty good rate. So how long will that take to double your money? I'm going to suggest you hit pause right now for a minute. Try to work it all out. Take your time to write everything down. When you think you've got the answer, come on back and I'll go through it with you. All right, let's have a look. If I want to double my money, this one was a little bit tricky again. It didn't give you any amounts, but it did say double, so there's a relationship there. I could start with an amount of money and end up with twice as much. Now I used 1 and 2. You could use x and 2x or 100 and 200 or 13 and 26. Doesn't matter, but 1 and 2 seem easiest to me, so that's what I'll do. Little I is going to be 15% divided by 4, or 0.0375. And again, we want to find n. This is going to come out in quarters this time, and we're going to have to convert it back to years, so we'll keep that in mind for the very end. All right, let's first start by finding n. N is going to be the log of 2 over 1, or just the log of 2, divided by the log of 1.0375. That's not too bad to work out. Works out to 18.82837199 on our calculators. Now, we want to convert that to years. So in this case, this is in quarters, isn't it? So in this case, to convert to years, I'm going to divide by 4 because there's 4 quarters per year. And that's going to give me 4.71 years, again, to 2 decimal places. Hope that worked out for you. There's lots more to try in the textbook and lots to read about it as well. So make sure you spend some good time going through this section. It'll really pay off as we go forward as well. That's it for now.